Hi, my name is Elise Hieronymus, and I am a member of the Chumbe Island Water Energy Nexus Challenge. First, I'd like to say I hope everyone is doing well during this crazy time during the COVID-19 pandemic. As I can imagine, many of you have been self-isolating for weeks now, but I'd like you to take a moment and imagine yourself on a small, beautiful tropical island in the middle of the ocean. You spend your days snorkeling, sun tanning, eating delicious food, and taking breathtaking images of the sunset. As the day ends, you go to plug in your cell phone GoPro so you can capture tomorrow's adventures. Life is good, life is perfect, and then bam, the power goes out. Chumbe Island, our client, is a privately operated island off the coast of Zanzibar, Africa. Chumbe's mission is to protect the surrounding coral and forest ecosystems on the island, educate the surrounding communities on preserving the environment, and promoting ecotourism. In order to fund conservation efforts for the island is home to a luxurious five-star eco-friendly resort. They pursue sustainable management practices by utilizing photovoltaic energy sources such as solar panels in order to provide power for the island's visitor center and surrounding bungalows. You can see the visitor center in the top of the photo and one of the bungalows in the bottom left corner. Chumbe Island currently stores their energy in lead acid batteries. However, as the energy demand continues to increase on the island, elements of their system, including their inverter and control system, cannot meet the demand, which creates a decrease of usable power across their entire system. The reason for Chumbe's energy problem stems from the fact that they store too much power in their system. The major subcomponents of their system include the solar panels, which are on the left side of the PowerPoint, which take in energy from the sun, the charge controllers, which are in the middle, and then the batteries, which store that energy, which are on the right side. Originally, the team thought that the only problem laid within the batteries. However, upon visiting the island, the team found another problem via the charge controllers, which were sized too small, meaning that potential energy would dissipate in the wrongly sized converters instead of being used. After the failure points were identified to be the controllers in the batteries, several different systems were analyzed, and a vanadium flow battery was deemed best for the island. However, upon visiting the island, concerns of economic feasibility were raised. So the team has decided to implement a short-term temporary solution that can be implemented on the island while Chumbe raises money to implement the vanadium flow battery. A vanadium flow battery takes advantage of the equilibrium equation in each electrolyte solution. The dual equilibrium equation takes a proton, pushes a proton across the membrane, which in turn pushes an electron through the entire system, which creates the electrical current. Through the system, this dual reaction takes place in the cell of a vanadium flow battery, which creates the power for the island. As you can see on the slide, here's what our prototype of the vanadium flow battery looks like. On the left side, you can see the team testing the flow rate of the battery. And then on the right side, you can see Hannah and Harrison mixing the chemicals for the electrolyte solution. A vanadium flow battery is the better option for Chumbe over their current lead acid battery system because a lead acid car battery only has a life cycle of 500, while a vanadium flow battery has a life cycle of 13,000. Also, the vanadium flow battery is adaptable, meaning to increase the storage power of the battery, the only increase that is needed is the is to increase the volume of the electrolyte solution. This puts Chumbe at a great position to increase their resort if they want to in the future. We are excited to continue our 4-year partnership with Chumbe Island. As a continuum of our Capstone project, we look forward to passing down our project to a future JMU Capstone engineering team. Our project, called the Water Energy Nexus Challenge, aims to understand the relationship between water and energy and the necessary energy transmitted. We hope to, with the future of our project, we hope to aid Chumbe Island in expanding their research efforts to bring awareness to coral reef preservation. We look forward to your questions and thank you for listening.